So we're here today to talk about using unstructured data to improve our business operations. This is one of those things that was kind of quite hard to do even 2, 3, 4 years ago, and really with the acceleration of AI technologies has become much easier to do to gain much deeper insight, which can really help to accelerate your adoption of the modern data culture, because it gives you more places to go to pull insight and information to make your business decisions. So quick introductions. My name's Lee Harper. I'm Catapult's lead for data science and machine learning engineering.
Hey,
and Rudy?
Yeah, thanks, Lee. I'm Rudy Sandoval, senior lead consultant for the data practice, Catapult.
Cool. All right, so agenda for today, we'll start out with why. Right? Why should we care about this, and why should we look to leverage this data to help us adapt this modern data culture? Then what do we even mean by this? What is unstructured data? What can it be, and what isn't it? We'll then talk about how you can actually use AI to start unlocking that, to really start gaining your business value from all the sources available to you. And we'll finish up with some case studies, some real things that have been done in this area, and then finally a demo that we put together for you to illustrate some of the points we're going to talk about. So, okay, so why should we go about leveraging our unstructured data? Why should we care about this topic at all? So let's say we're a chip company, and when I say chips, I don't mean silicon chips. I mean the tasty chips made from corn, potato, or something else delicious. And let's say in COVID we've got a best-selling product, and we want to capitalize on that best-selling product and figure out, well, what else should we make? What else should we bring to market? We could do a new flavor of chip, create a different texture, maybe make it from vegetables rather than potatoes, a healthier version, like a lower fat version. How do we go about deciding what has the best chance of success in the marketplace of those possible options? So traditionally, we might go to our structured data. These are our databases. These are, which could be SQL or Access. This could be our Excel spreadsheets. It could be really anything that lives in a table format. And let's say, in this case, we've got some store IDs, some dates, and just a number of sales per date. And what we might go ahead and observe there with that structured data analysis is that high levels of sales happen to correlate with locations where people tend to eat more healthily. Like, oh, great, well, that's fantastic. So we might then think, okay, well, people eat more healthily, they're buying the product. Maybe we should focus on that option, that buying the healthier version of our product. And that's the best we could actually do with our analysis using structured data. But was that the right choice to make? Well, traditionally as well, if we want to kind of get that deeper feeling from our customers, we go and ask our customers. This might be through focus groups or something else. But really, there's a wealth of information in those other kinds of channel of communication, right? They might be calling our call center up, talking to our call reps and saying, hey, I love the product, or to complain about the product. They might go onto social media and give a review. It might only be a few lines about, I'm eating this delicious new chip, go and buy some. It might be reviews left on online review websites. Perhaps they love the flavor, but in this case they're disappointed that it didn't have much crunch to it. Well, love is a really positive word. Disappointed is a bad word, and so ideally we'd have a way of associating those words with data that we can then use to drive that decision making. And of course, an email as well. They might be sending us emails to our comments about what they do or don't like. So this really does expand out the options we have for finding out why our customers love our product, and therefore how we can go ahead and create something new. But this stuff can be harder to use, right? And these are all examples of unstructured data, right? So data that does not live in a table, that doesn't have fields and rows and column headings and that kind of stuff. It's literally data that lives really anywhere. Voice conversations, unstructured text and emails. But these give access to us data sets that are really hard to obtain from those structured data sources. It's really hard to get a feel for how someone feels about something from a table of data. Much easier to do that from text reviews and from what people are saying and how they're saying it. So that's a very, very whistle-stop example of why it's something that we should really be caring about. And let me also be very clear here, this should not replace like your qualitative research, right? If you're already doing focus groups and voice of the customer, this doesn't replace that, but this can really augment it by doing that at a much larger scale than you can by going and actually doing it with individual people. So I'm going to talk a bit about what do we actually mean when we kind of use that term unstructured data. What are some examples of this, and really what can we start doing with that? So data exists everywhere, right? And I mean everywhere. So according to Gartner, who you regularly hear, well, everybody quoting because they do good research, they reckon that about 20% of enterprise data is structured, right? Databases, tables, all that stuff, just 20%. Well, imagine what we could do with the other 80% if we could start to leverage that. And we really are limiting ourselves by not incorporating those other kinds of data. Where could it exist? Well, we now have the concept of NoSQL databases, things like MongoDB, Cosmos DB in the Azure suite, that can store images and text as data very easily. It might be living on shared network drives. I know that kind of makes us all cringe a little bit inside, but we all still have those at our corporations, and a lot of data, both new and legacy, is stored there. Could be on cloud drives like OneDrive. Okay, people's OneDrives, again, store massive amounts of data. Within your enterprise content management suite, SharePoint being the Microsoft example there. If you have Azure or other cloud providers, it might be sitting in your cloud data lake. Right, those are very, very good places to store images and text and other such things. And also your web pages, right? Your website is a very, very rich source of data in its own right? And there's so much more there than just the IP logs, and login information that people have. So how do we, what do we do with that other 8%? What is that other 8% of data? Okay, and this is really all unstructured data. Okay, so not in tables. And this can really consist of anything, absolutely anything from which we could extract information. Okay, anything whatsoever. And there really is kind of no limit on what that can constitute. Like we might have a list today, in 2 or 3 years' time, that list might have changed. 10 years ago, or 15 years ago, social media data would have been like, well, what's social media data? Of course, now that's a really common source of this kind of data. And traditionally, this has been hard to leverage though, right? If I've got 1 million PDF documents, often that's required a human at large expense and large error rate to go through these things and pick out the data and put it somewhere it can be used. But now with AI technologies, we can do that automatically. And that's really the key here, is that advancement of AI has really opened up these doors to leveraging this kind of data in more and more interesting ways. So I know I've alluded to already, but this can include photographs and videos, very, very common, unstructured data, voice recordings, emails, PDFs, just 4 examples from hundreds that we could have given here. And the key here is how do we really minimize that manual intervention, because manual data is that's expensive, or it's a really, really bad internship. Right, I'm sure we've all had, or your most junior employee, you say, here's a bunch of documents, go and do data entry, right? No one wants to do that, and it's expensive. So the key here is then how can we, but machine learning models and analytics really is built around the idea of structured data. Okay, it doesn't really like just getting an image or text. So there is a key step here for also transferring that text data, that image data into a format, table, a matrix, that a machine learning model or a downstream Power BI report can actually look at, interpret, and do interesting things with. And that's where the AI comes in. All right, so although unstructured data, there's many, many forms of it, within kind of the analytics sphere, there are 2 primary categories that these data sets fall into that really get leveraged. Okay, there are some more niche ones, but there's 2 big categories that you'll hear people talk about a lot who are data scientists. And the first one is something called computer vision. Computer vision, It's actually been around for a long, long time. It's actually where I started my career, 8 years ago, was in this field. But AI, the use of the more advanced AI things has really accelerated at an incredible rate. And this is the idea of having images, really images of any kind, that we can pull information out of. Or indeed videos, right? Because videos are just sets of images. So 3 examples of this are in the top left there, we have optical character recognition. This is taking a photograph or a PDF of text. It could be typed text, or in this case, handwritten text, and extracting that text so it becomes, rather than being in your image, it's now in a Word document or in a Cosmos DB instance, which means you can copy and paste it around now or do interesting things with it. Or in this case, you see there's the word Oswald is highlighted. You can search it. So now you can search your PDFs, your image PDFs, as if they were Word documents, which is really powerful. Another area is detecting objects or recognizing objects. So in this case, we have that detects faces, not recognizing faces. That's controversial technology that I don't condone right now. But this just detects it. Now, how many faces are there in the image? So can I count the people? Right? Here it picked out 5 faces, or 6 faces, so there are 6 people in the image. That can be great for counting on street corners or counting cars going past, or really a range of things like that. And then we have the idea of form recognition. If I take a picture of a receipt or other kind of well-structured form, it could be your timesheets, it could be your HR applications, right? There's could be a range of different things that you do this for. It can then go through those images and extract all that structured data, because really a form is a table, right? When it comes down to it, and turn it into a real table in a real database. Again, a thing that would have been done manually before and now can be done automatically. These are just 3 of many, but they're 3 that we commonly see and work with ourselves and our customers. So that's why I picked them out. So the other big area that you'll hear about is now with language. We've done images, now let's talk about language. And I've called it here natural language understanding. You might also hear it called natural language processing. They're kind of 2 sides of the same coin. Processing is really around just doing text analytics using advanced techniques. And NLU understanding is more around, well, can I actually get the machine to really understand the context and the meaning of what I'm telling it? And that's a much harder thing to do, and that's actually really an emerging field right now that's very exciting for us. Again, 4 examples here of things that you can do in the NLU universe. So one is sentiment analysis, right? You probably hear about this being talked about quite regularly. If someone talks to me or writes to me, is it generally positive or negative, right? Are they happy or are they angry? Right, that can be a really powerful say for your customer service team. They get an email. If it's angry, you can flag it automatically to say this needs attention pretty urgently. Virtual assistants or virtual agents, aka chatbots. These are, what they say on the tin, right? You can type text in and it will hopefully understand what you're saying and give you good responses. Some can now be very realistic. They actually can almost make you think like you're talking to a human. Automatic translation, that's getting really good now, right? Google does it very well, as does Microsoft. And then speaker and voice recognition, which has come on in leaps and bounds in the last 5 years. I remember my mother in 2004 using Dragon Dictate. I don't know if any of you remember that. And it was like pulling teeth, right? Hearing her say, delete, stop, no, over and over again was frustrating. Whereas now, actually, as Rudy will show you later on, this works really, really well and is getting near to being perfect for a lot of people. So what can we do with this, right? These are some forms of it. These are kind of what some of it is, but what we really care about is how is it useful to us, right? So we can now make all, and I mean all of our documents searchable, not just our Word docs, right? We can understand why people feel the way they do about our organization. We can go beyond just the surface and really get to the why question, which is really powerful. We can respond much faster to positive or negative feedback from our customers or from our stakeholders or from our constituents, depending upon what kind of organization we are. We can automate those repetitive manual tasks that either you'd have to hire a data entry associate for, or our poor intern has to go away and do. And it also unlocks just more data sources for us to do our advanced analytics on, right? Our social media becomes opened up. Our call center is opened up as real data sources rather than just things that we store and keep for audit purposes. All right, so I'm now going to hand across to Rudy, who's going to talk to you a little bit about how we can actually use AI to start unlocking all those data sources I've just talked about in the last section. Rudy, over to you.
Awesome. Thanks, Lee. Appreciate it. Yeah, so it's exciting, right? So now we know we have unstructured data, and we have some options of different things we can do to analyze that data and try to unlock it. So the big question is, like, where do we start, right? So if we go to the next slide, one idea could be, hey, let's use some open source libraries, and these definitely have their place, right? When I first got started, I cracked open TensorFlow and tried to build a model. SpaCy is actually a really neat library that does some NLP, and so you can pick out keywords and things like that. But what these open source libraries bring is a technical challenge, right? So they definitely have their place, and they're pretty powerful. But this leads us to the next slide. Do I need a data science team? Oh, go back. So the question is, do I need a big data science team? Because these libraries, like I said, they have a technical challenge, and so it takes a lot of work to make sure that, one, you get the right predictions from what you're trying to do, and two, you have to think about scaling the solution as well. So a lot of it is up to you, right? So the question to this answer, though, is, and it pretty much always is it depends, right? So unfortunately, it's not a clear answer, but do you need a big data science team? It depends. But there's cases where you might not need it. So in this case, we have some just examples of ways to analyze your data, right? So the bigger the reward, the bigger the technical challenge. So you can start with Excel. So it's pretty straightforward. I've seen some amazing Excel sheets, so it can get complex. The technical challenge can go up there, but for the most part, it's pretty available, and the reward is minimal compared to some more advanced techniques. Then we have some BI dashboards, which are amazing as well, and they definitely have their place. And one thing we try to answer is, where's the sweet spot? So go to the next slide. Of course, the sweet spot we feel is right there in the pre-built AI model. There may be a use case where you need a fully customized model, and there's definitely a need for that. But a lot of use cases can be solved with pre-built AI models, and also could be a combination of the right pre-built models. So next slide, please. So one good thing about pre-built models is Microsoft is heavily investing in these pre-built models. So they have a lot of R&D. They've invested a lot of resources in making sure that they try to cover different areas, like what Lee was talking about, the different examples of text, sentiment, language, vision models, and they cover a wide base of different areas that they're researching. Next slide, please. And so what that brought us was all that investment turned into an AI as a service model. So before, the answer to the question of do we need a big data science team was probably because you need a lot of data, and you need to train that data, and you need to make sure that all that's managed properly. So before, the answer was yes. There was a lot of work in getting the model to where it needed to be. But now with AI as a service, a lot of things are available to us. And what's nice is the integration to the platform Microsoft is extensive. So you can have your own cognitive service for Microsoft and use that in, say, a website or even a chatbot. But you can also bring that into Office 365, and you can bring that into Power Apps. And what's nice about that is you get different levels of solutions. So you can have a no-code solution, for example, with the Power Apps. You can have a low-code solution and then a fully coded solution. So you get a good range of options with the pre-built models. And with pre-built models, there you can also, it gives you the opportunity to fine-tune them. So you can bring your own data as well. You don't have to bring terabytes of data, which is nice. But with fine-tuning, you can bring some of your data, unstructured data, and assist the pre-built models. So to get closer to reaching your goals. Next slide, please. So some examples of the cognitive services, the pre-built models that have been developed. A great one would be a content moderator. So this can scan text. So for example, if you had a public community, a forum on your website, it can be run through a content moderator, and it can detect adult content, profanity, and things like that. So it can be flagged, and then the flag could take that to a human if necessary, and then that way they can review it afterwards. So that's a great pre-built model that's definitely useful. And then speech services, like I mentioned before, you can use those for or Lee mentioned before, the translation functions and language understanding, which is great for that. That also falls under the text, so automatic language detection. The bot framework can be used for different. So the bot framework, I feel, is an interesting resource, since you can go and build a typical chatbot, that can answer some Q&A questions. But what I feel that is a more interesting solution is a virtual assistant, where you can take you can integrate it inside of Teams and actually have actionable items that you might want to do. There's pre-built language understanding models where you can kind of integrate it into a calendar. So if you wanted to have a Teams bot create an invite for you, that's definitely an option. And like I said before, you pick and choose kind of the right combination of the pre-built models, and that's what gives it the value and the power when you combine them. So another one is computer vision. So like Lee mentioned before, so OCR, kind of like the basic version of computer vision. And then the next step is the form recognizer, where you can take OCR, but then you can start labeling the data and start understanding, recognizing this is a name and this is an address. So you can start extracting context as well, and not just converting an image to text, but now you have context, which is great. Next slide, please. So one example of just a typical flow of the cognitive services that we normally kind of go through is we start with the data, right? So like Lee mentioned earlier, it could be pretty much anywhere. So we have a data lake, we have the cloud, or even SharePoint, right? So we got to start with the data. Then we bring it in to that combination of different services, right? To reach our goals. So, for example, you can start with the form recognizer and extract that context that we were talking about. Now you have that available to you, and then you can move that over and translate that information. So what's great about that is, so it's funny, if you did it in reverse, say if you had to say you needed to have a model that was available for different languages, instead of retraining different models, what's great is you can start with the form recognizer and then translate it afterwards. And so you still get all that context without having to kind of reinvent the wheel. All that kind of flows through, which is great. And then now that you have that information, you can index that into a search index and surface that to the users. So you can make that available, that whole pipeline available, and surface that fairly straightforward and fairly easily with the cognitive services. The search index is pretty nice because that allows you to set different fields, and you can search by different types and break things down even further. So it kind of unlocks the data even further. Next slide, please. Case studies. I think Lee has a great case study. We have 2 case studies to share. Do you want to share the first one, Lee?
Yeah, absolutely. All right. So this is just, and these are anonymized and they're just examples. This is work that we've really done for real customers. But the details of the customer aren't necessarily matching the real customer itself, right? So we want to make sure that we are fully anonymized on what our customers have done. So the first example, this is a PDF table extraction, right? This is using the form recognizer. So a customer profile here, an example customer profile here could be, say, a private equity firm. We've actually done this for a few FinServ companies, actually, things like this. Asset size, quite big, tens of billions of dollars. And it might be, say, their quantitative research team, right? Expensive people, they really don't want to be doing manual data input. So investment deals involve big PDFs, right? Big PDFs. And those PDFs contain lots of tables, right? I can't pretend to understand what those tables mean. It's way over my head. But again, traditionally speaking, the investment intern or somebody else has had to go through those documents, review them, pull the data out into tables and put it somewhere so the quants can go ahead and use it in their forecasting models, in their asset allocation models. So the solution here is to how do we automate that? How do we go through these big PDFs, pick out the tables, and then put the information in them into a database, right? So then it becomes easily accessible by a range of people and automatically. So the flow here looks like this, and we'll show an actual example of it in a second. But we have a data lake in which is just stored a whole bunch of PDFs. That could also be SharePoint. That could also be a OneDrive. But Azure Data Lake is a common place to put it as well. Then we actually use the form recognizer twice, not just once. We use it twice in 2 different modes. So the first time, go through all the PDFs and just pick out, well, what are tables, right? In this big set of text, what are tables? And then secondly, okay, well, now we know what the tables are. Let's pull that information out and put it into a SQL database. So one cog service, but used twice to get the desired effect that we wanted. So here's an example of one page on the left-hand side there. It's just one page, be a 60-page, 100-page document. So is to go through the tables, right? So in this case, on this page, there are 2 tables, and you can see they're also quite badly structured, right? They're different colors. They're not just black and white. Some tables aren't aligned, right? There are some misalignments there, things like that. So the first step is to go through and say, well, what is a table? And in this case, the information was able to go through and pick out the 2 tables on that page, but similarly able to pick out pages where there were no tables. Okay, didn't expect a table on every page. So then once we have those tables, so here's one example here, right, of one of those tables being extracted. Phase 2 then was to take that information, stick that into a table. Now, of course, there are some complexities here, right? You can see there are like indices, right? There are like, super suffices in the class A, class B, right? 1, 2 for the footnotes. So again, once that's extracted, they're pulled out as well. So that also requires a custom step at the end to remove that information and to terminate, say, on the percentage signs, which is the requirement for here. But the result is that we end up with, that table literally in a tabular format, and now our unstructured data, which contain tables in content, is now in a database ready to be leveraged for some advanced mathematical stuff by some super smart people. So that's a nice example of really using these tools to extract information that then you can go ahead and use for a new scenario. Rudy, over to you.
Yeah, so this also is a great project, because this, I feel, kind of is a perfect example of what we've been talking about, is trying to unlock data that you already have, that could be right now, it could be sitting there and it's an expense where you're storing data. So we had a customer that it was a university, mid-sized university, and they have a call log of students that have called in. They're prospective students looking for more information, and they can talk to the staff and get advised on different career options and different paths for education, right? So they have these conversations, and they store this data, right? And right now, before we worked on the project, they just had a big server storing all the calls, and it was a big expense. But what we did was we were able to extract that data and use the speech to text conversion and actually make that data searchable. So it took that data, and it feels like it turned it from data into information, right? So we can use that information now to do different things. We can reach out to marketing, and they can kind of detect trends and things like that, or they can use it for customer service training engagements and be able to search for specific things and use sentiment analysis for stuff like that. So next slide. So this is kind of like the process. So this is similar to what I mentioned before, like the whole process of the workflow, and we followed a little similar, but with a couple tweaks. So we had the call center database that had all the logs. They were in an OGG format, so we did have to convert those into a different format so it can the speech to text can understand that. But once they were converted, we processed them into speech to text API. And here we went kind of two different directions. One, we did the index into search, like I mentioned, so we can actually search by date range. So if we wanted to find something that happened a year ago or a couple months ago, we can narrow that focus. One interesting fact, though, about that is the amount of calls was pretty big. So they had 5 years worth of data, but it ended up being about 15 years worth of audio if you listen straight through. So it was quite a bit of data, which was interesting. And then we surfaced a search into a web application. We also, at the same time, after it was processed, we stored that in a blob storage, so we can use that in the future, right? So the next step is to do some NLP processing and not only have the text, but now we can add more context to that. So we go to the next slide. So we take that piece, right? So we have it in the blob storage, and we use text analytics to process that data, and that gives us a lot of cool information. So it brings out different entities, so it can label some of that information. So it can detect if something's an organization, a location. It can detect a date time range, and also if something's a person. It can also detect if there's PII data. So if there's some personal information in there, we can detect that and kind of hide that in the search results if we needed to. It also gives a sentiment, like we talked about before, and also key phrases. So it can highlight different key phrases that were talked about in that discussion. So like I said before, it could be helpful for marketing if they wanted to look for trends, and depending on the date range, we can see different trends through different parts of the year and see what more people are talking about, and that can help them focus more and better serve their students, which is great.
I think it's just worth really emphasizing here. This was 15 years worth of audio. It is impossible for a person to listen to all that stuff, and more's being created all the time, right? So it actually is physically impossible to see all of it, right? You have to use these tools to unlock that. There's no choice.
Exactly. It was a lot of data, and we were able to unlock that. So I just feel that was a great story, because it was just so much. The quantity was pretty amazing. And then so we have a little demo. Let me go ahead and do a screen share. I'll steal the screen share. So we'll try to do a live demo. Hopefully this this works well. So first, we built just kind of an out-of-the-box example of what the cog services are, right? So we kind of wanted to show the flow, right? So here we have the audio source. This would be like the ingestion part where the audio comes from. So this is the speech-to-text example. And so here's a blob storage. We have a file in here, and then we have the transcriptions, right? So normally if I can click on this and listen to it. Oh, I think I have to start over. 1 second. Let me reshare. Just a second. I forgot to check the computer sound box. There we go. If not, you wouldn't have been able to hear it. Okay, so if I click this, I can listen to it.
What's the weather like?
So pretty straightforward, right? Pretty typical. But if I do this, then we should be able to get a live demo. So I'll hit record here. It's recording my voice live. And so this, like I said, this could be a phone call, and you're recording the conversation between two people. You can also enable speaker recognition, so it can separate the two callers, which is great as well. So I'll hit stop, and then I'll name this demo, and we'll hit save. So now we have it in our blob store, and I'll play that back again. Record here. It's recording my voice live, and so this, like I said, this could be a phone call, and you're recording the conversation between two people. You can also enable speaker recognition, so it can separate the two callers, which is great as well. So I'll hit stop. So it's processing that, and we can see that it recorded it transcribed that. One other thing to note with all that data. So that the 15 years, it does take time to process. So one great feature of speech to text is batch processing. So you can actually upload that to a blob store and tell it to batch process a whole bunch of files at once. So that was necessary. If not, it would have taken a lot longer. And another thing to think about as well, one thing to consider is usually break up the process, right? So we have historical data that we want to convert, and then we have ongoing process from the starting point. So usually it's broken up. So that's something to think about as well and consider. But so now that we have it, right, we have the text has been transcribed. What do we do with it? So what we did was we sent that into Azure Search, and so you're able to use keywords to search, and if all went well, we get to see this is what we just recorded live, and it got sent to Azure Search Service, and we can see the file name and the content. So that's the unlocking part of the data. And the same thing goes with OCR. If we open this one up right here, we can see the example that Lee showed earlier, and if I come back, you can see that that data was extracted and also searchable as well. So that's a demo.
Okay, let me reclaim the screen share. Okay, well, thanks really for that. I'll say pretty high level. If you do want to see a deeper dive on that, there is a session this afternoon, I believe at 2:30. Our colleagues Roy Concepcion and Michael West are talking about how to actually build that from a technical perspective, right? He just shows you the front end. They'll go a bit more into how those cog services actually interact together, how the APIs work a little bit. So if you're interested in the technical side, do tune in to 2:30 on the technical track for that. So it's a natural companion piece to this one. Or if you're seeing this on the recording, find the recording for that. I'm sure it'll be a great session. Okay, so that's kind of our content for you. I know we're a little bit early, but I will use the time to plug ourselves. Oh, whoops. So first up, how do we do? This is the survey. I believe we have some gift cards. So if you're so inclined, you can scan the QR code, or I believe they're putting it in the chat. a link to that survey. I believe there are 2 gift cards, and every survey that you fill out, you get 1 entry. So if you come to all the sessions and do all the surveys, you get many entries. Be honest, but please be nice. We'll appreciate it. And so we do have a call to action, which for some reason didn't appear on my slides. So this is what Rudy showed there is actually something called our AI accelerator. And we can deploy a similar thing. It's packaged up. We have it at a fixed price. So we can come and deploy it on your data if you are so inclined. It could be speech data, image data. We can cover all those things and then help you to unlock something from which you can do some further analysis. So if you want to hear more about the AI accelerator, just let us know and we'd be more than happy to come and talk to you about it. All right, so with that, thank you very much. And I believe we can open the floor up to some questions. Feel free to chuck them in the chat, and our moderator on the call can let us know what you're asking.
Yeah, one person asks, do the services include a method to apply any extracted data as metadata?
So I'll give an answer to that question, and if it's not right, please let us know in the chat and correct us. When you apply the services to want a PDF or an image, the actual thing you get out of it at the end is just a huge JSON formatted object that includes all kinds of stuff, right? So let's say we're using the form recognizer. We not only get the text that appears, we also get metadata like its coordinates on the page. We can append like source information, like what document it came from is also in there. So huge amounts of metadata are generated by these that we can absolutely either extract at source or keep as much or as little as we want for downstream services. Or just save the entire JSON somewhere and then it's all there and never lost.
That is a good point. If it is stored in a blob store, you could also do that. Yeah, like what he's saying, you have that JSON file and you can update the metadata for that file in the blob store. So that would be a good option too.
Yeah, so I think the answer is yes, and there's many options available for you.
Someone else asked if we're using unstructured data to perform content analysis, if there's something wrong with this, how would we know? Basically, how would we know if the AI is coming to a good conclusion if someone says this doesn't sound right?
So that has a few answers to it, and there's various levels that you can go to. So the first thing, and this is with any AI system, right? Whether it's pre-built or whether it's custom, you should always evaluate it on data that you know the answer to before you push it into a production environment, right? So, and these are never going to be perfect, right? Speech to text is, I think, accurate about 99% of the time right now, which, there's still a 1% error rate that's going to occur there. And that's just, if the problem were easy to solve exactly, it wouldn't be solved with AI. So evaluating it, and there's various measures that you can do. I know the last session that was on designing metrics. There's many metrics that you can apply there. You can do, say with a search relevance, right? And that might be, there are metrics for that. You might just be, give it to some human users and say, how useful is this? You can do transcription accuracy for those speech to text services. You can do computer vision accuracy, measures of that, like the dice coefficient for computer vision. And with the aim then of that in that phase, hopefully you'll have a big picture view of how accurate these things are. Is it accurate enough for your use case? It may not be. Depends what you're doing. And then finally, what some common pitfalls are. For example, in that investment example I showed, those suffices, those 1, 2, 3 for the footnotes were a problem, right? We did the analysis. We found that was a problem for people searching and people's data. And so we put in an extra step at the end to remove that known problem, that known edge case. Now, let's say you pass that phase and then you've moved into production, right? So now your thing is being used, for real. it's always a good idea to do constant monitoring of that. That might just be, you know, every week you pull aside 3 or 4 examples and you look at them manually, right? If you've processed 100,000, you know, your time saving is really good there. Looking at a few, it probably isn't that stressful. It's probably a good use of your time. Things might go wrong though, right? As you say, as the questioner said, you know, things may not always sound right. In that case, go back to the data. You know, listen to the track, read the document and see again where the errors are, and then you can always go back to that post analysis phase and put in some more checks. You know, this regularly happens, right? This is and actually in 15 minutes there actually is a session on this topic called MLOps on the technical track. So plug for that session as well. And that's very much concerned with these kind of issues, right? How do you monitor your models continuously? How do you correct for errors continuously? And how do you keep the data fresh?
And also, in some cases, depending on how you're surfacing the data to the user, you can also think about putting a feedback loop, right? So if a user is requesting, maybe they're searching for a call log, like we just showed, and it doesn't return what they were looking for, there could be some a case in the UI to provide feedback, like they didn't find what they wanted, or they didn't find everything they wanted. So that kind of builds it. You can include that into your analytics, and that can help you drive and steer in the right direction of where you need to look to improve the results.
And didn't you build that this week for a client, Rudy?
Yes.
That exact thing.
Yeah, exactly. Yeah. It's fresh in my mind. There is one question I see in the chat that I kind of like. It's a great question. They record customer calls and they want to extract the info and do maybe some ordering, right? If they want to, if they're ordering from a call. What's great about that is in the speech to text extraction, it does look for pauses. So every time there's a pause, it creates in that JSON file, it creates a separate line, so you know when someone is talking, and so that is great for the natural language understanding. So you're able to extract individual sentences and feed that into the language understanding process. So that's how I'm saying that a lot of these work really well together, because they saw that it doesn't just give you one big block of text. It gives you each individual line, and you can use that for that exact same thing.
And back to the metadata, I believe it also gives you a timestamp of when that line started, right? So you can look for long pauses by looking at the difference between timestamps, right? You know, if a sentence takes 3 or 4 seconds on average, and you had a 30-second pause between sentences, that also gives you deep information about maybe what happened on that call, or if someone stopped to process a credit card payment or something else.
One more thing about call logs, depending on the system, what I found was interesting was usually one speaker will be on one channel of the audio and another speaker will be on the other channel. So it's easier to determine, you know, who's placing an order. So that's something you can also look at, where the speaker was coming from on the audio channel. So there's a lot of detail that you do get back, which is nice.
Do you have any more questions?
It looks like that's all the questions coming so far, but I have one for you too, which is earlier we were talking about problems that require data scientists to solve them versus ones that don't. What's the difference in those types of problems? How would we be able to identify that?
So I'll answer it, and then Rudy might have a different answer to it, because, you know, I come from the data science side and he comes much more from the developer side. We've now met in the middle, right? But that's kind of our backgrounds. So from kind of my side, whenever I'm kind of like talking to a client, my first port of call is that problem solved? Now, of course, I've been in this field for enough years now that I kind of have a good feel for what problems haven't been solved. But let's say, you know, you're on this course, is the first time you've heard about those, and you're saying, well, where do I go to, you know, kind of make my first steps? Search the website, right? Search cognitive services, see what's out there. You know, if you've defined a problem like, oh, I want to convert my, you know, text to audio, go and look for that. Does it already exist? That's always my first step, right? Is does a cog service already that does that? And I will always go there first if it does. Now, when to go for custom then is two cases. One, the cog service doesn't do what you want it to do, right? Let's say you're in a highly specialized field, right? Let's say you are a research lab at CERN, right? The big particle accelerator in Switzerland, and all your chat is about, exotic particle physics, deep engineering, and mathematics. A lot of the words you'll use there probably aren't in a normal lexicon. So in that case, because it's so specialized and so niche, you might need to go for something a bit more customized. And there do exist versions of this, by the way, for like medical science and stuff. So if like in a hospital, there are versions that can already account for like medical vocabulary. But then again, that defines during your testing phase. You would test the cog service, you'd find it didn't do what you want to do, and then you'd go and say, well, maybe I have to go custom. The other thing, of course, is that literally you want something that's so new, like, oh, that research paper that I read last week, I want to do that today. Well, that's going to require custom implementation because it's just too new to have got, to have been productized by Microsoft or somebody else. So those are my two cases that I would pick out. Rudy, what do you think? Well,
I think one great example was the use case that you had. So with the form recognizer, you do get a lot out of the box, but in some cases, like the tables weren't as straightforward a solution. So it required a little extra fine tuning there to get the correct data. So, but what's great about that is you don't always have to go straight to a data scientist, right? We can break these up into phases and get things started and kind of prove the concept out until we hit that wall, right? You hit that wall and says, this is not exactly what we're wanting. And so you reach the limit. And then that's when I feel the data science piece comes in where we can add that custom solution.
And as a kind of parting thought, Rudy, how would you describe your your advanced custom data science knowledge?
My custom, I start with the cog services first, and then once I hit a wall, that's when I call Lee because.
But then let me ask this question, Rudy. Okay, so that's where kind of you are, because you know some, right? But you aren't an expert in data science, right?
Exactly.
You are an expert developer. How many times have you deployed an AI system for our customers over the last year? Without
It's been
help?
Quite a few. So we've had about 3 or 4 big projects.
Right.
Right. Yep.
And you've been able to do that with no help from me, right?
Correct.
And that's the real power of this, right? You can have a dev team that already exists, and they really can, if they're smart people who want to learn some new stuff, like this stuff is really powerful and can be used by really any experienced developer. You really do not need a person like me involved. It can help, right, to help you design the metrics for measuring it, and for some of the more advanced bits that come after the cog services. But yeah, these really do work out of the box quite well, and can be used by people like Rudy who love machine learning, are keen about it, but just haven't got the years doing the custom work.
Exactly, and it lets me focus on the development side of things as well, and not have to worry about which model to use because they're accessible. So that's a great point, and finding that right combination to unlock the data.
And so Rudy and me make actually quite a potent team on these engagements between the two of us, right? So. All right, well, I think that's all we have time for. Thank you everyone for joining.